Today's module is about word recognition, or in other words, how we process the words that we're hearing in a stream of speech. Tomorrow we're going to be talking about how we process and understand words in context in a whole sentence, but today we're just going to talk about recognizing the individual words, pulling them out of memory, and recognizing as a whole unit each individual word. There are many theories that are proposed for how this might work, and one model looks something like this. As individual sounds are vocalized by the speaker, you might hear b, e, m, and as you hear those sounds, they activate a whole unit, a word, beam. Also, as you hear certain sounds, b, e, they activate similarly sounding words like beat. Now, interestingly here, we would find that, according to this model, the word beat should be slightly less activated than the word beam, because we did hear the sound and we didn't hear the sound t. So in this very simple model that we're starting out with here, we would see that both beam and beat should be activated, but beam would be stronger activated because all of the sounds of the word beam were vocalized. Now we'll come back to this model in just a minute because this isn't a complete model of word recognition, but this is a good start. Once we are activating a particular word, we find that some other interesting things happen. Like, let's say that somebody says the sounds lion. Once they say that, and the word lion is activated in our memory, then other similarly related words are also activated, like the words mane, roar, tiger, and cat. But words that aren't related, like fork and chair, would not be activated. This phenomenon here of activation is called semantic priming. Of course, you remember that the word semantic means basically the meaning of a word. So we're priming particular meanings of similar of words that have similar meanings. This right here is also known as facilitation, because we are making easier or facilitating the activation of similar sounding words. Now we know that this is happening because there are certain experimental paradigms that we can subject participants to that end up demonstrating that this actually happens. One of those is called the lexical decision task. The reason it's called the lexical decision task is because the lexical refers to the lexicon, or a set of words. Decision meaning to decide whether these are words or not. So the participant would see flashed on the screen a series of words like this: freedom, memdoll, wrench, book, Hannock, shorif, nurse, doctor. And of course, I'm showing you these in a list form because it's easier, but really what's going on in this task is that they're seeing the words one at a time, just one at a time on the screen: freedom, memdoll, wrench, etc. And the task for each of these words presented on the screen is to decide, is this a real word or not? And they push one button on the keyboard if it's a real word, and a different button if it's not. So here they would say real word, not real word, real, real, not, real, real. Now this looks like an interesting task, but the participant is a little bit tricked because this isn't the point. The point of the task is to see how fast they're able to push the buttons. So they're told, press the button as quickly as you can to decide if each word is real or not. And the only thing that the experimenter is really interested in is every once in a while they will pepper in two words next to each other that are semantically related. So if we show the word nurse to a participant, and then the very next word that pops up on the screen is doctor, we would expect, according to our semantic priming theory, that the word doctor would be more quickly recognized as a real word, and the participant would push that button faster to say this is a real word than if the word right before doctor had been like book, something that was not related to doctor. And in fact, that's what we find. If you show nurse right here, then doctor is very quickly recognized as a word. There are other similar tasks that we can use to get at a more subliminal or unconscious method of processing. The reason why we've invented this second method is because sometimes researchers have worried that if you pepper in too many of the semantically related words, then the participants will begin to seek for patterns. They'll begin to pick up on, oh, sometimes there's a pair of words next to each other that are semantically related, and I'm going to start looking out for that, and then activating, trying to guess what semantically related word might be next. In order to make sure that that's not what's going on, and that's not the reason why we see this phenomenon happening, researchers have used a similar task where they show secret flashed primes that are subconsciously processed but are so fast that the participant can't actually even see that they've been flashed on the screen. So these would be examples of how that happens. What they see on the screen is a series of pound signs. For just the fraction of a second, the word handle might be flashed, and then it immediately repeats the pound signs that they saw before. Because this is flashed so quickly, participants are not able to recognize that they even saw anything at all, consciously. But subconsciously, they've read the word handle. And then they're presented with the word shoe and asked, is this a real word or not? And they, as quickly as possible, try to say yes or no, that's a real word. But then in some tasks, or in some of the trials, they will be presented with the pound sign, prime that's related, semantically related to the target word here, will be flashed on the screen so fast they won't even see it. And yet, a second later, when they're asked, is this a real word? Because the prime activated that network of semantically similar words, then they will more quickly say vase is a real word than if some prime here had been an unrelated semantic word. Of course, throughout this task, just as you saw here, from time to time, there will actually be words listed that were not actual words, so that it's still a challenge, but I didn't have space in the slide to show that. A third kind of task is to track eye movements. In this scenario, you'll present a cross in the center of the screen, and the participant will have to gaze there. The researcher will present on the screen images and say the word hammer, for instance. The participant's eye gaze is expected to look toward the hammer, but because semantically related words are also activated in the mind, you'll see that their eye gaze also is torn and looks toward the nail much more of the time than towards unrelated objects like tissues or grasshoppers. This suggests that even though the word that was said was hammer, other semantically related words were activated in their brain, and they ended up looking, they couldn't help looking toward the semantically related lures. Interestingly, this doesn't just stop at the single layer of like hammer to nail, but it can continue on to other similar words that are related to nail, like screw. Even though hammers aren't related to screws, nails are related to screws, and a picture of a screw would also become a lure. This is how that would look theoretically. If you heard the word lion, all these other words I mentioned before would be activated. But other words similar to them would also be activated. So tigers have stripes, and that would be activated even though lions don't have stripes. So you might hear the word lion and have activated the word stripes, even though there's no reason why lion should be related to stripes. This is called mediated semantic priming, because this priming right here is mediated by an intermediate word. And the purpose for this in real life, of course, might be that it's easier to think about related words in a topic of conversation if that conversation is about a particular topic. So you can see why you'd want to have some kind of facilitated priming going on if you're talking about just, prisoners in jail. You'd want to have easily accessible in your memory all the different words that might be related, that might come up in the course of that topic of conversation. Now, given what I've just described in this process of mediated semantic priming, one might wonder if this just goes on in an infinite chain of words. Like if you hear the word lion, does that trigger the word tiger and then in turn the word stripes? After which you might think paisley, and then that might trigger for you the word shirt, which is related to the word tie, and that's related to the idea of neck. And of course, neck is close to the head, and the head is related to the word hair. And this could go on indefinitely. But we find that this doesn't actually happen. And the reason why is because we have a decay function at play, where the word lion is activated because you heard the sounds lion. But the similarly semantic words are also activated, like tiger would be activated, but not to the same extent as lion. It's a weaker activation. And similarly, stripes would be activated in turn from tiger, but stripes would be weaker still. And by the time you get to something like paisley, a fourth order, the activation has completely died out, and we see that no longer are these words activated. This brings me to another idea, which is inhibitory connections. So you recall back to the beginning of this lecture when I was talking about these, the activation of a word like beam, and how if you heard the sounds beam, they would excitatorily activate this word beam. Interestingly, other sounds, if we hear them, they inhibit the potential for similar sounding words to also be activated. So in this image, you see now the word beat is not activated, even though we heard sounds like b, e, and these have an excitatory connection to the word beat. But the reason why this isn't activated is because when we hear the sound that inhibits the activation of the word beat, and it makes it less likely to be activated. If we were to hear the sound t, we didn't in this situation, but if we were to hear the sound, then that would have inhibited the word the word beam, and that would have inhibited that, and it would have activated, it would have excited the word beat. But because we didn't hear this sound t, then these inhibitory and excitatory connections are not in play. Instead, what we do see is that once the word beam is activated, there's an inhibitory connection that stops the word beat from being activated, so that we don't get tripped up over similar sounding words. If we had activated the word beat by finishing this t sound here, then the word beat would have inhibited the similar sounding word beam instead. But this inhibitory arrow here is not in play. So you can see that what we've got going on is some excitatory connections from b, e, but they're also trying to activate b, e in the beat, but because we've got inhibitory connections here from the and from the whole word beam that stop this word from being activated, then similar sounding words are not activated in your brain. And we can see that this is the case using the same methods that we described a minute ago in the lexical decision task. So if you had, again, a list of words, and I didn't present these, but some of these, of course, would be nonsense words. But if you're going through the list and you eventually get to a couple of words here that sound similar to each other, like stiff and still, if you read the word stiff in this sequence presented on the screen, once you read that word, the word still is less likely to be activated, So it would take you a longer period of time to recognize that this is in fact a real word. And so your button press there would be delayed. That suggests that this word here has in fact been inhibited, like I described theoretically on the last slide. You can also see that in the subconscious priming task, where you might show words that are unrelated to each other and see no relationship. But if you see words that are phonologically related to each other, structurally related to each other, like sling and slink, if you're primed with the word sling, then when you see the word slink and are asked, is this a word? You take a lot longer to recognize that it is in fact a word. And that suggests that, in fact, this sling, once activated, inhibits the word slink so that it's harder to bring that into the forefront of your brain. We can also do this again with eye gaze. If you hear the word beetle, for instance, then that inhibits the similar sounding word beaker. And your eyes are far less likely to go toward that word. Now, the final thing I want to talk about is how sometimes we have multiple words in our mind that are represented by the same sequence of sounds, and yet they have different meanings. Like bank ends up activating either one of two possible interpretations. For instance, this could be a financial institution housed in various branches, or it could be that land by a water's edge, the bank by the river, or the bank by the lake. So in order to differentiate between these two possible activations here, we have to rely on contextual cues. So if the context is Samira just got her paycheck, and then we're going to say something about how she took it to the bank, then this priming about the paycheck would activate from the context the potential semantic features of a financial institution housed in various branches, so that when you hear later on the sounds bank, that activates this word right here. And even though this word will also be activated, this first definition of bank will try to inhibit the second definition of bank, the water's edge. Even so, we do see that sometimes in these situations where the word bank might be activated, the second meaning of the word bank still is activated to a lesser extent. And we can see that in sophisticated experimental tasks where we're trying to figure out, again, like lexical decision making, can you recognize that like the word river, which is semantically related to this word bank, if the word river is more quickly activated after hearing a sentence about Samira taking her paycheck to the bank, and in fact it is, river is more quickly activated, which suggests that despite this inhibitory action here, this word is still being activated to a greater extent than we would expect just by chance.